Hello, everyone.
Hello.
Hello, everyone. We're still waiting for our presenters to arrive. Okay, while I am letting everybody in, Carlos, you can take over.
Hello, everyone. First, let me thank all of you for taking your time and to be part of this presentation, this amazing presentation that Shirley Virgin and Jorge Vasquez will be presenting today. And they are going to talk about the utilization of AI machine learning for Alzheimer's disease classification. So I will let you with Jorge and Shirley. Okay. So guys, you can start.
So greetings, everybody. I'm gonna get the presentation pulled up, but just to introduce myself and then Chiale as well. My name is Jorge Vasquez. I'm a senior computer science scholar, originally from Honduras by way of Tampa, Florida.
For sure. Greetings, you all. I am Chiale Briggins, a fourth-year computer science scholar from Miami, Florida.
And today we're going to be going over our presentation for the research we did this past year, which was non-invasive Alzheimer's detection via MRI imaging and convolutional neural networks, a deep learning approach to early detection of Alzheimer's disease. And a big thank you to Dr. Carlos Teran as well for being a part of this and helping us along the way.
So first and foremost, before we get deep into our research, what is Alzheimer's? Alzheimer's is a neurological disorder that leads to the decline of cognitive functions, including memory, reasoning, and language skills. So that can go to the run-of-the-mill things like knowing how to put on clothes, tying ties, even driving, and some in very dire cases, sometimes forgetting some family members. Nearly 7 million Americans are living with Alzheimer's, and it's projected by 2015, 13 million people will be suffering as well. Caregivers for people with Alzheimer's or dementia spend about 18 billion hours, which can nearly cost $347 billion. 1 in 3 older adults die with Alzheimer's or another form of dementia, and the lifetime risk for Alzheimer's at age 45 is 1 in 5 women and 1 in 10 men. So let's start talking about invasive techniques for Alzheimer's detection. There's things like CSF analysis, which require lumbar puncture to collect spinal fluid, which measures biomarkers like amyloid beta and tau proteins, which basically means that they cut into your back and collect the fluid that comes out of it to test to see if the patient have Alzheimer's. PET scans, which involve radioactive tracers to detect amyloid plaques and tau tangles into the brain, which just means that they're subjecting the patient to radiation to see how their body reacts. Biopsies, which are rarely used, require the removal of the brain tissue for direct analysis. And so after talking about invasive techniques for Alzheimer's detections, let's talk about MRIs, which are non-invasive, safer, less expensive, and widely accessible, which also provides structural and functional brain data without physical intrusion or exposure to radiation, which can be obviously, as a patient, a little bit more wanting. So why is machine learning being used to detect Alzheimer's and dementia? As technology advances, using AI in other fields is its only matter of time until it is used in the medical industry. Machine learning is properly programmed on how to detect patterns in the brain can save millions of lives. One of the biggest pluses is that it has the potential to catch early stages of Alzheimer's to help people more aware. So of course, if we don't have to go through a whole surgical, process, we'll be much more, it'll be get to a quicker to a point to find if somebody has Alzheimer's or dementia.
So to move into more of our research or a deeper look into our research, what machine learning models were implemented? So we use convolutional neural networks and a subnet of convolutional neural networks known as the VGG16. The CNN that we use is a type of artificial neural network that is used to process and recognize images. CNNs are a subset of machine learning and a key component of deep learning algorithms. They are often used for computer vision and classification tasks. VGG16, though, is a convolutional neural network that excels at image classification, and it's like a highly trained image analysis who can dissect a picture, identify objects and scenes within it, and categorize them accordingly. And as well as what is a convolution, which is the mathematical process in which the algorithm works to identify what is the next stage that it should go to when it's working. So a convolution is a mathematical operation in which an image is filtered by applying a kernel or a filter that slides over the image to detect patterns such as edges, textures, or features in computer vision tasks. Essentially, what that means is you're giving your computer a set of eyes to detect what it's looking at and to understand what it's looking at as well. So first, it converts an image into numbers. From there, it's able to use each pixel represented by a numerical value to normalize the data and then use these filters that are multiplying the grid size by itself to slide over and create a mathematical operation, like we said, called convolution, where it's multiplying the filter values by the pixel values and then summing them up by highlighting the features, edges, textures, and shapes. From there, it goes into its pooling layers, where these layers reduce the size of the image by summarizing nearby pixels. It keeps important features while discarding the unnecessary details, making the model more efficient. And as you can see in the GIF right here, it classifies the number 7 into the current or the output layer by going through all the layers and then finding the one that it looks most like. After many, many layers of filtering, it's able to do this. And for our research, we actually use this because of the classification being so efficient. After the flattened layer is fed into the fully connected network, like a regular neural network, the network then assigns the probabilities to each class and makes a prediction based on the highest probability. So for our methodology and how it differs from other people's, our methodology is different because not only do we use the raw image, but we also use a certain filter, a Gaussian blur, and a segment stack. And other people in the past were doing the same thing, but they weren't applying these filters, the Gaussian blur or the segment stacks, in order to get their results in their data. And we'll see later on how our data is different from theirs and what our accuracy and prediction scores look like. But overall, they came out to be pretty good. So to go a little bit deeper into our methodology and how it works, we had to collect our data. This consisted of going through many different brain MRI scans and categorized as Alzheimer's disease and healthy ones as well, to kind of split the data into training and then test sets. And then from there, we kind of, went through our model and figured out where we needed to figure out a bias, our precision, accuracy, and then our F1 score from there. We then selected our model. Like I said in the beginning, we had a CNN architecture as well as a VGG custom, which is two separate algorithms to test our data collection. We then trained our model, which was through Python, TensorFlow, and Colab to share the code. And from there, from testing our model, we were able to analyze the results and classify them into one of four different categories, one being no Alzheimer's disease, two being mild Alzheimer's disease, three being severe Alzheimer's disease, and four being a complete loss. And for future improvements, we hope to refine and improve the model by experimenting with other architectures, tuning hyperparameters, or expanding the data set for better generalization.
So how will we go about knowing if our research worked without metrics? So here are some of the things that we used to evaluate whether our research and our program was actually efficient. So of course, accuracy, indicating how often the model correctly identified whether the patient had Alzheimer's or not. Specificity, this metric tells us how well the model avoids fake positives or how well it correctly classifies healthy patients as not having Alzheimer's. Sensitivity focusing on the model's ability to correctly identify patients with Alzheimer's. A high sensitivity meaning the model is good at detecting Alzheimer's, but also minimizing the false negatives. And then, of course, kind of like what Jorge mentioned, the F1 score. The F1 score is the harmonic mean of precision and recall. It provides a single metric that balances the trade-off between precision, how many positive predictions are correct, and recall, how many actual positives are correctly predicted. It's particularly useful when there's an imbalance between positive and negative classes.
So we get to how well our models performed, and miraculously, we actually did really well with both models. So our CNN model achieved remarkable performance in classifying Alzheimer's disease images with a whopping overall score of 96%. The precision, recall, and F1 scores across all classes consistently demonstrated the model's robustness, particularly excelling in class 2 with a precision of 96% and a recall of 98%. These results highlight the model's reliability and effectiveness in accurate classification across diverse categories. Now, this is not the same for the VGG. Although the VGG is a lot newer, it still applies the same way the CNN did, with an overall accuracy of 85% and an F1 score of 0.88%. And despite the slightly lower overall accuracy compared to the CNN model, the VGG model demonstrated reliable classification capabilities, particularly excelling again in the class 2 case. And in comparison to other models where we see the same data set that we used, as well as the Myriad data set, we had a very, very close precision, accuracy, sensitivity, and F1 score to that of somebody else who did the same tests, but with only the raw images and not with the same filters that we were using and everything along that line.
So in final, let's talk about the contributions to society that our research can have. Improved diagnostic accuracy. The hybrid model developed in the study showed very high accuracy in predicting Alzheimer's or dementia. This contributes to more reliable diagnosis and have a solid way of diagnosing people without having to, of course, have surgical practices done. Early detection and intervention. The machine learning model being tested in the study can help detect Alzheimer's disease in its early stages. Of course, like I said, if we don't have to go with a surgical model, we can just have people do MRI scans and have machine learning let us know if they do have Alzheimer's or not. Public health implications. With the increase of global prevalence of Alzheimer's disease, the development of automated and accurate diagnostic tools could now have a profound impact on public health.
So we want to thank everybody once again for coming out. And any questions?
Yeah. Yeah. Can I ask a question? This is Richard Lowe. Very nice results. Very, very impressive. Congratulations. So I have a couple questions. What do you plan to do with these results?
So with the current results that we have, we're actually writing our first research paper alongside Dr. Teran. He's kind of guiding us through that process, and hopefully we're able to get our first publication from both me and Chiale in the future.
Yes, sir.
Wonderful. Congratulations. That's what I've been pushing in this program, and I'm glad to see you guys move into this. So what do you think is your next step beyond publishing the paper? What would you like to do next with this or with anything else in, say, data science?
I think the next step is kind of creating a system. Like, so for our research that we did this year, we used a data set that was already kind of categorized. Like, we already knew if somebody had Alzheimer's, or like we already knew what category they were in once we had the MRI scans. But I guess the next step is kind of creating it in a way that we don't need to already know that we have so much faith in the research that it's already.
So both of you, you're both computer science majors. What kind of statistics courses did you have before starting this research?
I actually never took statistics, but I took linear algebra, which is another like really big thing that they use in convolutional neural networks, because everything is considered a matrix and all that. So although I never took statistics, I understand the system, and hopefully in the future I'm able to take.
Yeah.
What about you, Kylie?
Chiale.
Chiale.
Yes, sir. I took statistics in high school, but every computer science student at FAM is required to take discrete, which isn't 100% statistics, but it does have some of it I worked into it.
Okay. So what are your plans after graduation?
So currently I'm hoping to continue researching stuff like this, but I actually have an offer on the table from Northrop Grumman to work as an associate electrical engineer.
Cool. Congratulations.
Thank you. Thank you.
For myself, I'm currently still in school, but I hope to take my internship with STARS to the next level and hopefully get a full-time offer with them post-grad.
Okay. Very good. I have other questions, but I'll leave those to later. Let other people ask you questions. Very nice work. Very, very nice work. Very proud of your work.
Thank you.
Yeah,
Are there any other questions?
there was a question. If you look in chat, Dr. Lowe and
Yeah.
Del, somebody wants to go back to, hold on, to the image scan slide. Yeah, Jalen wants to go back to the image scan slide.
This one? I'm not sure
Jalen?
which one is the image scan slide. I'm sorry. This one, I
Oh,
think.
sorry. Can you all hear me?
Yes.
Oh, yeah, perfect. Can you keep scrolling up? Keep going.
That's the beginning of the presentation.
No. All right, scroll. I think you missed it. Scroll down, my
Okay.
bad. Right here.
Yes.
No, scroll up a little bit.
This one?
The one right before.
This one.
Yeah. This one. So my question is, with you all's methodology, did this flowchart that you all made and diagram, was this like put together by you all, or with the pre-processing and like data transformation stuff, did y'all do the work that is necessary to do the raw image and Gaussian blur stuff?
Yes. So to answer that question, throughout the code, we initially had to start with, implementing our data set and everything like that. So we had all the images being run through at first. The second part of our code was applying the filters. So then we had the raw image, the segmentation, which is the line trace around the whole thing, the Gaussian blur, which was to blur the image, and then as well as the thermal filter that you see there as well. And that's kind of how we transform the data for normalization throughout for the algorithm to process it in our methodology versus what everybody else was doing, which was just the black and white images that you see on the left side there.
Perfect. You know, I'm in computer engineering. I'm studying computer engineering, and I'm actually doing digital image processing, which is exactly what you just explained. So very awesome. Thank you.
Yes, sir. Thank you, Jalen. Any other questions?
So what about, go ahead, I'm sorry. Go ahead.
Yes, I have a question. So looking at what you guys done so far, the question I have is what kind of data do you think you would need to improve your system and your accuracy? I'm thinking things like maybe the age of the person, the history, family history of the person. Have you guys given any thoughts to what else? Because basically could be to improve your accuracy, you might need a different data source or data stream. So I'm just wondering, have you guys considered what else you might need to help improve the overall system?
Yeah, so this conversation came up kind of last time that we presented it, and me and Jorge and Dr. Thrang came to understanding that I think the next level would be, of course, like you said, knowing somebody's particular family background, also in finding out what type of work they did in terms of like what their lifestyle was like before their MRI scans and things of that nature. Do they have any other types of cognitive disorders, possibly things of that nature? Kind of like, again, like a nature versus nurture thing of like how did they get here today, and if we can get as much information about that, of course that would make our data all the more specific and accurate.
So in that line, you're talking about like what we call health determinants, but in that line, what about wealth? Does wealth make a difference? Do you know?
I think so, particularly because again, it's about like where you were before you got your MRI scan. So if you're a little bit more wealthy, you might have a little bit more you might have the resources to have better care of, like, I guess not your brain, but like how active your brain is working out, how strong are those neural links, but that are withering away if you have Alzheimer's, dementia, that type of thing. So I think it definitely does play a role into it.
So have you thought about a master's degree in data science or a PhD? This is commendable work, you guys.
Yes, I have thought about both getting my PhD and something around this or related to this with like health classification, just being able to apply what we know with machine learning in the health science field. I think it's very important that, both of these things are coming together, because with the power that we have here, we'll be able to make better inferences. Like you guys said, we need more health determinants and stuff like that. And some of that stuff is locked off to like private institutions and stuff like that. So the more information we get, I'm pretty sure the better our classifications will get over time.
Oh, yeah. Other questions?
I did have a kind of follow-up
Go
to
ahead,
questions
Erdell.
right here.
Yeah.
Right now, the actual cause of Alzheimer's kind of still elusive. We kind of know what to look for, in terms of the plaque in the brain that gives us the hint that something is going wrong, but we don't actually know the mechanism that causes this to happen. I'm just wondering if you guys feel or believe that this research can help in that part of the problem in terms of actually figuring out the dynamics that cause Alzheimer's.
Definitely. I kind of think of it kind of like as a reverse trickle down effect. If we're able to diagnose, if we are able to get more people, we get more MRI scans that we're going to be able to run through the research. We can find more people who have had Alzheimer's or who have it, and then kind of sit down with them and actually like ask them about their process between here and what they're being born in here. So how did you get here? What type of lifestyle are you living? And then over time, with talking to more people who have had the chance to use our research, we can find a better, we can find a common denominator within that. I hope that answered your question.
Just to add on, I think what Chiale is saying is very, very true. You know, the way that you grow up is very important when it comes to stuff like this, because you never know if it could be something like your diet or the way you lived when you were younger, what you were seeing, what you were applying into your life, and all these different aspects. So hopefully in the future, we are able to see and meet other people that had or are going through this issue now, or, you know, have somebody in their life that is related to them that, you know, they might have it as well, and they're trying to get this kind of work done. And, you know, maybe we could sit down with them and kind of apply what we did here with them.
Oh, what do you think about sensor data? If they could, do you think there's anything at all about if they had body sensors, you could determine something?
Yes. I mean, that's a little bit out of our scope that we had for this project, but I do think with sensors being a big thing now, or just like, you know, how we have like a BMI, like a body mass index that kind of breaks down like everything in our bodies currently, we'll be able to classify all these different aspects and all this different data to, you know, refine this kind of model more and more. And from there, hopefully we're able to get a better classification through that information.
Yeah. Have you heard about behavior? I'm sorry, go ahead.
We have a question from Joy Caring
Go ahead.
in the chat. Would you guys be able to tell someone has Alzheimer's based on conversations, or would you still have to scan the brains in order to tell?
I say we still have to scan their brains or at least get an MRI scan. You know, within, and this is something also very important to our research that we talked about a lot is by no means do we think that this is going to be the end all be all today, you know, especially when you're dealing with health and with people's families and things of that nature. You can never say, oh, you definitely have Alzheimer's because this machine has told me that. No, you kind of have to go in the roundabout way of saying, well, our research is leading us to believe, or this, that, the third. So yeah, definitely, we would definitely need to still get an MRI scan to see if somebody had Alzheimer's or dementia.
Just to quickly add on as well, when it came down to, you know, our classification and everything, we had our scores. Like Chiale was saying, it's kind of hard to determine. And, you know, this is an ongoing process. It's hard to determine if somebody really truly has Alzheimer's if they don't get an MRI scan. Without the MRI scan, this project wouldn't have been capable of being done. And, you know, I think this work that we did this semester was very good. And as far as like classificating, if somebody were to, or classificating if somebody's images of their MRI scan were, you know, non-demented, moderately demented, severely demented, or a total, like just lost cause at some point. But yeah, we worked very hard this semester to figure out what we were training, what we were testing, and we came back with really good accuracy and scores. So hopefully we're able to continue refining this data to have better results at the end of the day and to continue seeing some of the future works that we hope to have for this project.
So how many semesters did you work on this?
Two semesters. We did it for this semester and then the previous one. So about a year.
And I also want to mention that we have a lot of chemistry and biology students, engineering students in the audience who can definitely bring a different perspective to this research. So all this is, about joining sciences, joining efforts to solve the problem. And I hope we can, inspire those people as well to pay more attention to these issues and bring their expertise into the research.
Yes, ma'am. I agree. I think we should be coming together across all STEM fields to look at health science and stuff like this because
Okay.
it's important.
So you realize that healthcare is a national priority, and big data science and engineering is another national priority. And so I'm impressed that you did this in 2 semesters. You have publishable work, and you've made advances in the field. So this could be a turning point in your careers as you look forward. You should really think about going on to graduate work in this area. AI is just a part of data science. Machine learning is a part of artificial intelligence. So I really want to congratulate you guys. You did a wonderful job in 2 semesters. Did you use any calculus in this?
No, sir.
I, that's the point. The point is that this is a beautiful way to broaden participation in STEM. Okay. It's always been held that, everybody needs to go through calculus. Calculus is important for many fields, in engineering and others, but you can start in data science without calculus, depending on the domain you're working in. And eventually you might want to have to use calculus depending on what domain you're working in. If you happen to be working in a domain like civil engineering or something like that. But you see what you can do with discrete mathematics. This is all about discrete mathematics. Beautiful. Great work, guys.
Thank you, Dr. Allo.
Thank you.
There is another question here from Dr. Maurice from Droid.
Yeah. Go ahead. Is it in
Okay,
chat?
all right.
It's in chat, yeah.
Do you guys think you will be MDing into other mental illnesses?
I mean, that would be awesome to definitely see how we can use machine learning and AI to make advancements in other cognitive diseases. I mean, that's just a question, of course, but we got to finish this one. We got to finish this one first with our paper.
Would you like to add anything, Vasquez?
Yeah, I'll add on. So I think that we will look into other mental illnesses once we kind of develop this one a little bit further, like Chiale said. Yeah, I hope to do that in the future. So hopefully with more time and more research, we're able to, diversify more than just Alzheimer's disease and maybe even go into data science and other diseases as well. I know Dr. Teran is doing research with other students that are also a part of the speaker series that they're looking into diabetes, and I think that's also important too, like looking into just other diseases that a lot of people have that haven't been necessarily solved yet and that can be prevented for future cases. So yes, I do think we will look into other mental illnesses in the future. Yes.
So, yes, I'm glad to hear you say that. We are looking, Dr. Thuran, myself, Dr. Mativa. We actually even are developing a program with a university in Bielefeld, Germany, in which we're talking in particular about Alzheimer's, Parkinson's, dementia, sometimes called diabetes 3. And we're looking at some of these issues that you all raised, in addition to some others that I mentioned to you. So this is an international problem. We hope to create an international institute on artificial intelligence in healthcare. We're very, very interested in healthcare. So I really strongly encourage you guys to keep going in this direction. You're making a contribution that will have a big societal impact. I think we can help solve this problem by, first of all, identifying onset, trying to identify onset, and then what can we do to mitigate progression? Those two big questions. Yeah. So I hope you guys will continue in this. It's a fantastic area, a big societal problem. So I don't know. Do we have
Okay.
other
Yeah,
questions?
okay. Any other
Odell?
questions? Yeah, any other questions?
Well, if there's no other questions, I do want to thank your mentor,
Yeah.
Carlos Terán Suarez,
Thank
for
you so much,
bringing
Dr.
you
Terán.
students on board.
Yes,
Carlos, are you with us?
I'm still here.
Yeah, and of course. Wonderful presentations, Carlos. We really appreciate this, and we appreciate you taking the lead with these young people.
No,
Be sure they go on with this. Don't let them get away.
the commitment of Jorge in Chile, they will not be possible. But they have done a really good work.
Yes, yes.
to just add on, it wouldn't have been possible without Dr. Teran here, who kind of helped us in developing the code overall. He really led the way on this project.
Let that boy out of jail.
Who was that? Who helped you? Who helped you on the code?
Nah, I think that was somebody else speaking. But yes, it was Dr. Teran.
Oh, wait a minute. Say that again. Jorge. I did. What did you say?
I'm sorry.
Oh wow, those are so cute, right? Where'd you get those?
Okay.
Yeah, what I was saying was Dr. Teran led the way, and he really guided us through this entire project. So it wouldn't have been possible without him, for real.
But you were talking about the coding or
Oh
something?
yes, he led the way through the coding, and he helped us overall in understanding like where we were in different aspects of the code and everything. So, like I said, it wouldn't have been possible without him.
Of course. Yeah.
Definitely. Dr. Theron does an amazing job at the CIS building, recruiting students for the research. I know a lot of students who really wouldn't have been interested if it wasn't spearheaded by Dr. Theron. So
Yeah.
thank you again.
Okay. Kudos to you all. Erdal, do we have anything else, Erdal?
No, that's it. I think we can take one more time to just congratulate our two presenters, and then just let everyone know that if you guys want to continue the work, you can contact us, either myself, Dr. Taran, Dr. Alo, Dr. Mativa, and we certainly can get you guys moving in that direction.
Yeah, I also want to congratulate the students and Dr. Tiran and Dr. Lau, Dr. Erdel, everybody who participated in this project. This is wonderful, and it shouldn't stop by any means. Just keep going. Thank you. Thank you, guys.
Thank you.
Thank
Thank
you.
you guys for the messages.
Yes.
Okay. So, Erdal, do you want to add any other anything else in chat, Erdal? Are we clear in chat for questions?
Yes, we are.
Okay.
With lots of congratulations.
Okay. Thank you, everybody. Take
Oh,
care.
hold on.
Oh, go ahead.
Oh,
What you got?
What stand out most, or what is most important to you about the presentation, Dr. Alo? A question to you.
Wait, to me, wait, what does this say?
What stand out most?
Most, or
Yes,
is
in the
most
presentation
to you about? Oh,
for you?
many things, many things. First of all, the time frame. You see what you were able to accomplish in 2 semesters. You were able to make significant inroads, significant statements. That to me is amazing. The other thing is you see where how much discrete mathematics now plays a role in such areas, and that discrete mathematics can allow us to broaden participation in STEM. There are a lot of young people like yourselves who probably have dropped out of computer science because of the calculus, okay? All right. But that doesn't mean you should stop. Data science is about it's about big time computing and data. So you still have to do big time computing. So don't let, if you're getting out of computer science because of the calculus, look at data science, because you'll still be in the computing area, you'll be in the mathematics area, and you'll be able to make a societal impact. That's what you guys have shown. That's why I asked you the question, how much statistics did you have? Okay, but you did have a discrete course. Okay, see, this is what I was driving at. We're very concerned about broadening participation in STEM. The number of young people coming into STEM in high school, from high school, has dropped considerably. Okay. And then the number that do come in and major in STEM, there is an attrition, a big attrition. We want to stop that. And you've demonstrated that there is a way to stop that. That's what I appreciate. That's why I kept asking you those questions.
We appreciate your questions, Dr. Ilo. They were very great questions. And yes, I do think one of the most important things when it comes to work like this is the impact and the legacy that you're leaving on the world. When you work on health science and technology and just STEM in general, what are you doing that's changing the world?
Yeah.
I think that's one of the most important things. So yes,
That's it.
thank you guys once again for allowing us to work on this project and for all the love and support that we got from all the comments that everybody made.
Well, don't walk away from it. Stay with it.
Yes, sir.
Make the impact. That's what we need. We need to democratize, put it that way. We need to democratize this field. These algorithms are not written necessarily by people of color, okay? So we need to democratize. There you go.
Yes, sir.
Thank you, guys.
Yeah. Thank you, guys, once again.
Bye now.
Yes, sir. Thank you, everybody who showed up today. Thank you once again. And I think we can close out the meeting for right now.
Thank
All right, for all
Have a
those
good one.
who needed attendance, once you signed in with your FAMU email, or you typed your name in, your full name and not, just A's phone, then we will be able to get your name as attending.
Thank you, everyone, again.
Yeah, let's smile.
You guys have a good one, okay?
Thank you, Lee. Good
Yep.
work.
Thank you, guys, once again. Have a good one.
Bye, Jorge. Thank you.
Thank you. Have a good one.
Bye, Maurice. Thanks for everything.
All right, no problem. All right, everybody. I'm cutting you all guys off. I give everybody a chance to say whatever they got to say. Bye.